Welcome back to part 2 of Microsoft Azure Virtual Training Day, DevOps with GitHub. Now, in this session, we start with Module 4, Delivering Changes to Cloud, and wrap up with Module 5, where we'll talk about incorporating performance testing in your CI/CD pipeline. So let's get started. Now, this is the 4th module in our learning journey. Now, in this module, we'll focus on continuous integration and continuous delivery or deployment, which is often shortened as CI/CD. Continuous because DevOps refers to deliver value by keep trying, keep adopting methodology. We'll also go back to the idea of trunk-based development and protection of secrets, which we shortly covered in Module 2. Now, we are familiar with Tailwind traders by now and how they're trying to accelerate delivery using DevOps. Now, CI/CD is another key element in DevOps. The I in CI refers to integration. Think of when you and your teammate work on 2 different features, and you both need to merge it back to main branch. Integration is especially tricky because your changes need to work with everyone else's changes, but they don't necessarily do. For example, if both of you add a new feature in your user profile, you may change the same file, and at the same time, your version of code still needs to build and your own tests still need to run. Now, D in CD can stand for delivery. Delivery as in delivering a new feature or a fix. Now, the issues here are how to make sure that you have a deployable piece of work, how to include infrastructure and dependencies for it. Essentially, it is a problem of how to deploy from a built image to testing, staging, and production environment. Now, D in CD can also be deployment. Now we are concerned with how to deploy a certain version of piece of work. For example, how to push forward a certain release. Now, it's not just production, but also maybe a test environment or a UAT environment. The issue here is to make sure that deployment is trustworthy and reproducible. Now, let's make the distinction clear. CI concerns the development phase during build, test, and validating the code. Continuous delivery concerns the automation of delivery. Once a new build image is there, it should be deployed. Continuous deployment concerns from when you commit into a for production branch or to a version prepared for a release. Everything else after that is automatic. Common practice is to have a pipeline which defines a CI/CD flow. Example, when we have a new commit in a main branch, we first do some automated tests. Then if passed, we deploy it to a test environment. Then if someone responsible for checking like a product owner click approve button, we deploy it to production. Now, one thing to keep in mind when it comes to CD is that we always want to have a continuous deployment or delivery to somewhere. Remember, the end goal in DevOps is to continuously deliver value. And we do that by ensuring our delivery or deployment practices put our build artifact in some environment. Further, we should be very careful not to always assume an easy and clean deployment. Even with testing and a validation during our CI stage, we still need to perform some additional tests and checks during the CD stage as well. Now, we have already introduced you to GitHub Actions in Module 2 and Module 3. Now, finally, let's take a look at how to do CI/CD with GitHub Actions. Again, when you use GitHub, the best option for CI/CD is perhaps GitHub Actions. The actions are the definition that provide automation integrated natively within the GitHub environment and is often used to build CI/CD implementations. Your GitHub Actions will be defined in YAML files, which you can commit into your GitHub repos. Then they get executed by GitHub on the cloud or by self-hosted runners. You can reuse templates from large number of existing actions in GitHub Marketplace, which will let you start fast. While there are other options for pipeline like Azure Pipeline, GitHub Actions work natively with GitHub. GitHub Actions allow you to set up CI/CD pipeline very easily with most cloud platforms. It is quick and simple with existing templates. Example, GitHub Actions for Azure. Now, at essence, GitHub Actions will provide you automation for any software workflow. Dozens of events to be used as a trigger for your actions and CI/CD. Now, let's take a look at GitHub Actions work with CI/CD. Now, we have recently identified a bug in our Tailwind Traders application code. We aren't able to get applications inside to show properly on our Azure portal. So a member of our Tailwind Trader team has opened a pull request to resolve this. Drilling down into the PR, we can go ahead and merge this change from a short-lived feature branch into a main trunk branch. When we merge, a continuous integration workflow will kick off. And we can see that workflow is running here. Let's take a look at what's happening. We can see our workflow is automatically completing steps that make sense for this application. We are logging into Docker, building, which is our full .NET build and test workflow, in this case of this application, and then pushing our application container image. Great. The build artifact produced from this workflow contains the fix for our application insights to work. Now we need to get this out to production. To do this, we need to add a continuous delivery to our process. Heading over to Visual Studio Code, I have a CI workflow up. This file contains the steps we are going to use to currently build and push our Tailwind Traders application container image to our container registry. It's pretty straightforward, and as the application build steps are contained in our Docker file, we tag the build image with SHA of the current chain so we can trace our current image back to the particular point of code base. To start, I'm going to switch to a branch that I've already created, because while we want our changes on our trunk as soon as possible, we don't want to work within it. I went ahead and updated our CI workflow with a second action stage. This stage will be our deploy to production environment. You can see here that on line 42, we can also see the stage needs, or it's dependent on the first stage where we build our image. We can also set specific environment variables for each stage. Proceeding to the steps we defined for this stage, checking out our code, we ensure we are logging into Azure, and then we add a step to deploy our websites to Azure App Service using the build artifact, the container image we built in our previous stage. You'll notice that this isn't just deploying an image, it is deploying all the resources we need for this application to run in production. To do this, we are using Azure Bicep. Now, Azure Bicep will ensure we stand up the infrastructure needed, an app service plan, and our app service resource itself. We can take a look at Bicep file here. This is where we start by setting up parameters for what our application needs. We can pass environment variables to those parameters. We define a resource for our resource group. And for our web app, we call a module. This is called a second file where we list the resources our web app needs. In this file, you will see we define our app service plan and properties we need, as well as the website or app service itself. We can also define our app settings right inside our Bicep file, which will help ensure an easy, clean, and streamlined deployment. Here is where we can securely pass a registry username, password, and server URL through from the GitHub Actions. Heading back to our CI workflow, you'll see lines 69 to 72 is where we are using GitHub secrets to pass data as parameters to a Bicep deployment file. Let's push these changes now so we test them out and get our application insight fix out to the production. Now, what we have defined in the steps is that we need to deploy to production. We need to ensure GitHub knows about a production environment. Heading back over to GitHub and navigating to settings, we can scroll down to environments, and we are going to add a new environment. We'll call it production, and we'll hit configure environment. We can also configure protection for these environments. For example, we can restrict which branches can and cannot deploy to this production. Since this is production, we only want our main branch to deploy here. I can click this button here, scroll down to selected branches, so we can specify our main branch. Once we have branches selected, we can add our deployment branch rule. We'll simply type main and hit the add rule. Great. Now we want to ensure we require reviewers before deploying this to the environment. We want to control what can and cannot be deployed here. Remember, this is all about protecting production. I'll add some team members and click Save. Okay, we have a continuous delivery workflow defined with the steps that make sense for our production deployment. And we have a production environment created and protected. Let's open a pull request. Now, since I'm using a fork, I'll make sure we are making a PR into the main branch for this fork. We'll call this PR adding continuous delivery capability, and we'll hit open. After we open our PR, we'll merge this into main, so our production code in main can get out to production. After this merges, our CI will kick off, which we can see in our Actions tab. This is going to run through the same steps we previously did. Log into Docker, build, and push a Docker image. Only now, we will also take a look at that build artifact, that container image, and we'll deploy it into production using the second stage we wrote. Now this is great. We can get our fix to our application insights not only packaged up as a build artifact, but we can easily carry it out over to our production. You'll notice our deploy doesn't just roll out to the production since we protected it. We need a manual approval before we deploy to production stage. Now let's approve. I'll click this link and select environment I'm approving for. We can leave a comment if you wish. I don't do this for this demo. And let's click approve and deploy. And now our second stage can now execute the task that we define. All right, due to the magic of video editing, our workflow and thus our deployment is now complete. I can see the summary of the stages and the workflow. And you'll notice under our deployed to production stage, I have a deep link for our production environment where I can check out updated production website. Now, another concern is how to protect production or how to make sure unwanted changes don't go into production. Now, a typical CI/CD workflow is triggered by a PR. Example, a team member work on their own feature branch locally. When they're done working, they create a new PR. The workflow or pipeline triggers automatically upon the PR creation. In the workflow, we first build the code. Then we run some automated tests. Then maybe a new version of app gets deployed to a testing environment. Checks and approvals are done by developer, testers, and stakeholders. And if all checks are passed, we merge it into the main branch. Now, this corresponds to traditional branching strategy that you may have seen in Module 2 before. But as you may have seen before, you can use a different strategy called a trunk-based strategy. Now, everyone here starts from the main and go back to the main branch. The main branch is also called as the trunk in this strategy. When someone starts on a new feature, they create a new branch based on main. They work on it and merge it back to main when done. Same strategy can be used for a bug or a quick fix. Now, these short-lived working branches are sometimes called as topic branches. Remember, short-lived means literally short, like less than a day, not less than a sprint though. When branches hang around longer, they become long-running branches, which leads to a merge hell. A good example of this can be two engineers working away, making commit after commit to their own working branches, but neither of them are seeing each other's code. Maybe a day or two later, developer A merges their code into main, and developer B pulls main and tries to merge. But now developer B must deal with a ton of merge conflicts. Depending on how long these branches have been around, there are thousands of lines of codes to review. Now, if you want the workflow to be automated as much as possible, it can be set up so. Someone creates a PR. PR triggers a build and deploy into an auto-generated environment created only for this PR. Team and stakeholders will review this PR on its environment, merge the PR, and auto-create another app instance with its own environment after the merge. Now, there's a problem here. Should we set up the production environment stick to main all the time? You can do so, but it's a little risky because you do not necessarily want to always show the newest changes to your users. And you may want to combine multiple PRs to release to maximize the value for end users. A safer approach is to create release branches from main when you need to. That means certain merges get promoted into. Kind of like snapshot of the main at a certain timestamp. Now, do not commit. That means work on these branches, otherwise it gets too messy. Now, time for a quick demo. As we saw in our last demo, deploying to production is great, but the cloud enables so much more. Let's pick up where we left off. We have our previous CI build we used to publish to production. Our steps are pretty simple. We build and push our image in our first stage, and we deploy to production environment in our second stage. We know we are using Azure Bicep to create our app service and app service plan resources for our production environment, and this is working well. But let's enhance this workflow for pull request validation. Starting from a feature branch, I have a PR workflow YAML file open. You'll notice we can and have set a trigger for that pull request to fire off. I can choose what it fires off, open, synchronized, or even reopen PRs. This ensures as the PR is open and the changes, our actions can respond. We can also define our environment variables and ensure the number for the pull request is captured and added to that environment variable automatically as part of our workflow. Take a note of how we have used predefined GitHub PR environment variable to add a suffix for our resource group and web app names variable as well. We'll use them in a minute. You'll notice that we are able to reuse our previous steps, Docker login, Docker build, but this time we can pass the appropriate variables for the environment we are working in, a pull request validation environment in this example. In our deploy stage, this time we opt for our deployment to go to a PR environment using the resource group name and web app name variables I mentioned previously. Notice how similar this workflow looks like to workflow file we built in demo 1. The only thing changing right now is the environment we are deploying to. Let's head over to GitHub to see what happens when we open a PR and this workflow is triggered. I've already opened a pull request. You'll notice the first stage of our workflow completed successfully. This is the stage where we built and pushed our Docker image our PR will use. And I can see our second stage, our deploy to PR environment stage, is currently running. Excellent. The deploy stage is completed successfully. Like we were able to do it in our first demo, we still have access to deep links to our PR environment right from within GitHub. I can use this to view our PR deployment. Great, this works. Our website is up. Let's flip back over to GitHub to take a note of the steps we executed for this workflow. Notice that the steps are same as we use for production environment. We're even using the same bicep file, just with different environment variables passed to those parameters. This is important because it means we are creating a test environment that mirrors a production environment. This allows for accurate PR validation. Now let's head over to Azure to see what these created resources look like once they have been deployed from our GitHub actions. From within Azure subscription, you'll notice I have two resource groups, TWT website, which holds the resource for the production web app we deployed in demo 1. And I now have a second TWT website with suffix equal to my PR number, 19 in this case. Drilling down into this resource group, we can see the two resource objects we declaratively defined in our Azure bicep file. We have our app service plan and our app service for our PR website itself. Drilling into this PR app service object, you'll see the same URL we have access to in our GitHub actions. This is the URL we use to access our site. Heading back to our GitHub actions, we can merge this pull request, and since this looks good, we can see our new PR workflow file that we created functions as designed, and it's time to merge it into main. Remember, once we merge to main, our CI/CD workflow for main will kick off, and we can see that workflow currently in progress. Now drilling into what is running, we see our build and deploy to production stages we defined in demo 1. Just like in demo 1, we have reviews required before we can push our changes into production. However, as we have talked about, we may not always want our changes to go to production. Instead, I want to stage these changes. I want these changes to go into pre-production environment before going to production. I'm going to reject this release for now until we can update our workflow with further steps. The last thing we want to do is clean up our unused resources. After we validate our pull request and merge our changes into main, there's no need to keep our PR resources up and running. They're costly and no longer of use. We can run another workflow to trigger on any closed state pull request. You can see that this syntax on lines 3 to 5. Note that we are still passing the same environment variables, so this workflow knows which resource group to clean up. Now, the magic of cleanup happens right here on line 21. It's a simple Azure CLI command to delete the resource group specified. And here we pass in our resource group name and use a yes flag to allow this command to execute in a non-interactive manner. Great. Now let's head back to the slides and move on with our training. Now let's take a look at some of the tools that help us getting into production. Now there's another nice feature called deployment slots that will really help you. A few past services on Azure, like the app services, has this feature. Now why do we need it? Often when deploying apps, we need environments, commonly used as test, developing, staging, or production. Staging is usually right before production, and production is what end users see. In a traditional setup, you may see two different environments, which stick to two different branches, say one for staging and one for production. But with deployment slots, you can set up multiple slots for one app. Now, each slot represents one environment, which matches to one application instance. You can choose which branch or which repo to publish from. You can even decide how much traffic goes into one Example, when releasing a new feature, you can have all the traffic going to staging initially. Or maybe you have 100% of your traffic going into the production slot. Now, when you do a deployment, you can deploy it into your staging slot and either test it directly. Or if you want it to move, you can move 10% of your traffic here. Now, this will allow you to test it before releasing out into the wild. Now, this is often known as canary deployment. Or if you just want to do a straight swap, that means deploy to staging or swapping the slots, it's more of a blue-green pattern. You can get more creative with this too and use feature flags or load balancing to roll out new deployment of features out to a subset of users, maybe based on geography. But how do you actually make these changes? It is important to note, whatever configuration models you have in your production, your pre-production environment should match that. This means if you have a production app service using 2 deployment slots, staging and production, you should also have your stage before production match. In our next demo, we'll walk through configuring a workflow with a UAT. UAT stands for User Acceptance Testing. We'll use this to stage run for our integration test, visual test, and any other smoke test. We may need prior to promoting to our staging slot in our production environment. Take a note how our UAT environment also gets its own staging slot. Now let's go ahead and check it out. We are back on our code again, and we are working on a short-lived branch, this time called user acceptance. Development environments are helpful, and so is our approval gate. But we really need more control of our deployment. We need to add a stage before our code goes into production. This is a stage where we can perform our integration and visual test before we promote R to final production environment. Luckily, adding a quick stage for UAT, user acceptance testing, will be pretty easy. You'll notice I already have added in that code. And really, I only need to tweak a few parameters in our infrastructure as a code. Now, after our image is built, it will be deployed in a UAT environment for testing prior to receiving approvals for moving through to production. You'll notice in this UAT stage, we still have this stage dependent on build image stage. And we have simply updated the environment variables that we are using. We just changed our web app environment variable to include a UAT identifier. Now that we have these changes, I'm going to go ahead and check them in. We're going to make sure that we push our user acceptance branch up to our Tailwind Traders repo, and we'll head back over to GitHub to take a look at it. Now, like we have done several times now, let's open a pull request. Great. Of course, because this is a PR in our PR workflow we've built previously, and it will fire off. But due to magic of video editing, we'll just skip through it and get to the main point, enabling our UAT environment. Fantastic. All our steps from our PR are completed successfully. Let's get this merged into main. We'll have this third stage added to our process workflow. I'm also going to delete this branch. Remember, when I close any PR, we now have a PR workflow that will execute to clean up any unnecessary resources that a PR used. At the same time, we have our merge workflow running. Drilling down into what this workflow run is doing, we can see a new UAT stage. Again, this is the stage where we can perform our integration and visual testing prior to approving promotion to production. Once our deployment completes, you'll notice that we have the same deep links over our UAT environment, so we can run those tests and verify if the deployment was successful. Transitioning over to Azure portal, we can see all our resources. We see now we have a UAT resource that have been created by updated workflow. We can also drop into our configuration settings and see these settings are the same as production and have been updated to reflect the information passed to a bicep file for this UAT environment. Infrastructure as a code for the win with consistency in environment. Now this is great, but still not enough control. We need even more. Heading back to Visual Studio Code, and again, working on a new branch, new change. New branch, we are going to add a slot support for our deployment environments. This will allow us to execute different deployment strategies, such as blue-green if we want to slowly route traffic from one instance over to another, or if we want to stage our changes in staging slot and then swap slots when it's time to go live into our production. We've tweaked our configuration even more. We have added support now for staging into our infrastructure as a code. We have updated our bicep file to accept a new staging parameter. And we have added a staging slot resource to our configuration, so our infrastructure will automatically be provisioned with this slot. Now let's go ahead and get this checked in again, and we'll head back to GitHub. Now we'll open another PR, this time for adding staging slot support. And we know our PR workflow will kick off again. Again, the magic of video editing helps us. And the PR workflow completed successfully. We've also merged our PR to main. Now, as we know, once we merge to main, our full workflow kicks in and we can drop into the summary tab to check out what's happening. Here we see our deploy to UAT is running, and there's now a fourth stage to deploy to production staging. We deploy into staging slot in UAT because we should always practice like we play. How our production environment is configured, our UAT environment should exactly match. You can see here that in our deploy to UAT stage, where we have a final task after our deploy web app, this new task will swap our deployment slots for our UAT environment. This helps us uncover potential process problems as we swap slots from UAT staging slots into our UAT production slots. To ensure this mirrors the experience as closely as possible to our production, when we deployed a new container image, we set UAT's production slot to use the current production image. The only difference in our production environment is that we have used another approval to protect the slot swap that we have done automatically here. Now let's take a look at these resources and how they look in Azure. Now when we look at our UAT web app, we can check out deployment slots, and you'll see we have a slot we can use for production and a slot we can use for staging. Now these are the slots that are being used for swapping during the final task, just like we talked about. However, if needed, I can perform a complete swap here, as well as providing me a way to roll back in case of critical incident. Drilling down into staging slot, you'll notice each slot gets its own URL that you can use for validation or smoke test as well. In this case, we can check out and see our application has deployed successfully. And we can run our integration testing and decide whether to promote through to our production staging or from production staging into a final production environment. Thanks to these updated stages and configuration updates and the availability of our cloud services, our continuous delivery process can provide a control flow from development into production. Now, another typical issue in DevOps is the credentials. In application these days, we need to add all kinds of credentials. Example, to connect to another backend API, or to another service, or to another database. Traditionally, these are often kept in an environment variable in your computer, which are at risk if someone hacks into an OS level. Now, GitHub allows you to create something called as encrypted secrets. Now, the encrypted secrets are encrypted, so no one can read them. You can create them easily at a repo level or an organization level. And you can create these on GitHub UI as well. Now, in your GitHub repo, you can find it under settings, and you can hover into secrets, and then you can create a new one. Once created, no one can view these secrets. Once they're stored, you'll never see them again, even if they're used in actions. Now, GitHub does its best to strip them from logs as well, but there are some limitations. The secret might be used in a number of places, and if they're changed, you need to change it from all the repositories, and you need to remember where they all are. Now, this is particularly important in the case of a security incident, where you need to kill all the creds immediately. It's generally a good practice to cycle credentials on a regular basis. The person in charge controlling these credentials will also need access to every repo that they use. And if that's your ops team, it can scale quite badly. You can easily pass these secrets into your workflow as inputs or environment variables. Quick attention, secrets are not automatically passed to runners. It is best to avoid passing secrets in command line arguments. Now, an alternative to GitHub encrypted secrets is Azure Key Vault. This is an Azure product, so it has nothing to do with GitHub. Different from GitHub secrets, it can store more than just secrets, also keys and certificates. Also, Azure Key Vault allows you to have a single point of control managed by your Azure AD. The sensitive information is centralized and managed by appropriate people. And the workflow simply pulls those credentials just before it needs them, using Azure credentials that can be controlled centrally as well. Now, when you're using Azure Key Vault, you can simply call the secret in your GitHub Actions configuration file. So it is really easy to set up. Now, Tailwind Trader is thinking of new ways to implement all the things that we have learned so far. They want to rotate credentials in Key Vault when an admin asks a team board. automatically build a new dev environment, and fork a new repository based on properly formatted issues. Pull a commit message since last production release and build release notes for customers. Now, in summary, we have learned how we can add CI/CD to our workflows. We have learned how to continuously deploy to somewhere. We have learned how we can protect production. And we have even learned a bit about centralized secret storage using GitHub Secrets and Azure Key Vault. Now, this brings us to the end of our module 4. Now, let's go for a quick break, and I'll see you on the other side.